Hello and welcome to the i3 podcast. My name is Wouter Klein and I'm the Director of Content for the Investment Innovation Institute. For more information about our educational forums for institutional investors, please visit our website at www.i3-invest.com. There you can also subscribe to our complimentary newsletter i3 Insights, in which we discuss investment strategy and asset allocation questions with asset owners around the world. Now, as you all know, we love our disclaimers in this industry, so here's ours. This recording is for educational purposes only. It does not constitute financial advice. Please enjoy the show. Welcome to the i3 podcast. In this episode, we're going to take a look at artificial intelligence, machine learning, and natural language processing. We will discuss some of the recent advancements, including ChatGPT, how they can be applied, and interesting investment opportunities in this space. So our guests today are two great experts in this field, Anthony Goldbloom and Professor Chris Manning, both who originally hail from Australia but are now based in the US. And besides their other activities there, they also get involved as investment partners at venture capital firm AIX Ventures, a venture capital firm that invests in businesses that has artificial intelligence or machine learning at the core of their business model. Anthony, let's start with you. Apart from your role with AIX Ventures, you are also the founder of Kaggle, which is an online community of data scientists solving machine learning problems in the form of competitions. And Kaggle was taken over by Google in 2017. So Anthony, sounds like you've been a busy man.
Yeah, it certainly feels that way, but all with good things. You know, I wear two hats. I'm the founder of the company Kaggle that you mentioned, and left 6 months ago to found a new company called Sumble, and then also through the AIX, doing investing in AI-focused companies. But I actually think the two reinforce each other. You know, being a participant in the AI ecosystem gives me a lot of sort of hands-on feeling for, what are the important breakthroughs that we need, and what are the sorts of things that AIX might, should consider investing in. What are the gaps in the market? So yes, I definitely feel busy, but at the same time, I do think I'm working on things that reinforce each other nicely.
Yeah, fair enough. So let's take a step back. Machine learning and artificial intelligence is at the moment very much in vogue, but how did you sort of get started into the area?
Yeah, sure. So my background's actually probably similar to the background of a lot of people that I imagine are listening to this podcast. I come from an econometrics background. You can tell I'm Australian originally. I graduated from Melbourne University. My first job out of college was at the Australian Treasury. So I was forecasting GDP, inflation, and unemployment. And then after that, I went to the Reserve Bank of Australia, where I was doing the same thing. In both cases, I was in the macroeconomic modeling areas. So I was always had been a hobbyist programmer, and I came across, I guess, this kind of emerging field, machine learning. I became very interested in the idea of applying more automated approaches to training models, or to building models, than what we typically in econometrics would use these very handcrafted approaches. And I started learning programming languages like Python, and started looking at trying to apply some of the techniques I was learning out of my job in my job. And that's how I first became interested in, I guess, the field of machine learning. And the way I certainly in the early days of data science, machine learning, my definition of a data scientist was somebody who knows more statistics than the average programmer or computer scientist, but more programming than the average statistician. And I certainly fit that bill. And there was this small kind of niche, or maybe it wasn't a small conference. It was actually a large conference. The conference was called KDD, Knowledge, Discovery, and Data. And one of the things this conference would do every year is they would run a challenge. And if you won the challenge, you got a speaking slot at the conference. So you could submit a paper like everybody else, or you could compete in the competition. And I always thought that the competition was a really elegant idea for deciding in some ways, submitting a paper is a little bit subjective, right? Does the reviewer like your paper or do they not? There's something very elegant about who had the most accurate algorithm on a machine learning problem getting to present their work, because you could objectively tell, who had built the best algorithm. And I found that idea very attractive. And so I left the Reserve Bank and started working on building Kaggle, which was really taking that idea that I had seen in academia and wanting to apply it to industry. And so the initial idea behind Kaggle was that any company could host a machine learning challenge, and that any data scientist who was interested in trying to solve that challenge could compete. And the winner would win prize money, and in exchange for the prize money, they would give the intellectual property over to the company that hosted the problem. So maybe to give you an example of an early problem, we had one of our first customers was Allstate, the large US insurance company. And they wanted to predict which cars were, or which drivers were more likely to be in an accident, who should have a higher premium. Claims prediction problem, very standard insurance problem. And it turned out that the results they got out of the challenge were quite a lot stronger than what they had been able to develop internally.
Right.
And so that was a consistent pattern in all the challenges that Kaggle ran.
So Gaggle had also that sort of competitive element to it, where people could sort of submit their problems, and then whoever had the most elegant solution, I suppose, won the competition. So that came sort of forth from this initial participation with your own sort of algorithms.
The winner wasn't the person with the most elegant algorithm, but the most accurate algorithm. Because the way the competitions would work is we would give participants two data sets. We'd give them a training data set and then a test data set. Let's take that insurance example I gave you. Allstate, you're trying to predict who's going to crash their car or who's going to make a claim. So in the training set, we would give those who are competing maybe data on 100,000 customers, and we would tell them, this one made a claim, this one didn't, this one made a claim, this one didn't, right? And then we'd give them data on another 50,000 customers in what we called the test set. And we knew the answer on the test set, but we never revealed the answer. And so people would train their algorithm on the first half where we gave them the answer, and then we would measure their performance on the second half.
You could test whether it was working because you already knew the answer on the test set.
Yeah, exactly. And then the idea is if you had an algorithm that worked on that test data set, then you could apply it at least for problems that are stationary. And a lot of financial markets problems, I don't meet that category. But for problems that are stationary, what worked on the test data set, then assuming it was a representative test data set, would then work on sort of would generalize to the larger corpus of Allstate customers or whatever it is. One of the reasons Kaggle became quite high profile in the machine learning AI world is before Kaggle, you had all these people with different backgrounds who were trying to do relatively similar things. And you had econometricians for economics, you had statisticians for a lot of social science problems, you had bioinformaticians for genomics problems, you had computer scientists and machine learning people, and each had their own pet methods. In econometrics, it was generalized linear modeling. In computer science, it was support vector machines and random forest. But every discipline had their own set of techniques. And one thing that became very clear in the early days of Kaggle is one technique won problem after problem after problem.
Okay.
And so all these people who had such very, very different backgrounds all started converging on this technique. The technique was random forest. That was the technique that just dominated the early competition. And two things happened at the same time. Kaggle kind of came up, and this term data scientist became sort of like an umbrella term for people who historically had all those different backgrounds. And so those two things coming together at the same time, it kind of allowed random forest for a good number of years became the way you solve problems. And then that got overtaken by another approach called gradient boosting machines. And then, in around 2012, 2013, we started seeing, particularly on computer vision problems, neural networks and deep learning start to take over. And of course, that's the genesis for a lot of the, 2012 is often called the annus mirabilis for machine learning and AI. It was the year that we went from, more of these older style methods to deep neural networks. Then in call it 2018, we had the transformer model, which came out of Google. The deep learning came out of the University of Toronto primarily. 2018, we had the transformer model, which came out of Google, and that led to a large increase in what was possible on natural language processing. And then since then, I guess it was also 2017, there was diffusion models, and that has then gone on to, become, these models have gotten bigger and bigger and bigger until today we're using things like GPT-3 and ChatGPT, which are very, very large transformer models. And then some of the models like DALL-E 2,
Yeah.
the ones where you type in the text and it generates images, and those are very large diffusion models.
Yeah, I actually had a bit of a play around with the DALL-E model. It's kind of interesting. You can give sort of short terms and it creates these images. But at the same time, it was sort of interesting to see. So this is sort of from the Open AI platform, but I think Google had their own version, and they sort of looked at what I produced and said, oh, this is actually probably causing a lot of intellectual property issues, or they had some objections from sort of an ethical standpoint against it. How do you look at that? But especially what we've seen around ChatGPT as well, with students cheating on it. But at the same time, if I look at it and had to play around with it, I'm like, well, it's interesting, but it's not necessarily that sophisticated yet in terms of what it produces.
Yeah, I mean, I got to tell you, I disagree with you on the level of sophistication. I'm mind blown by what you can do. I use GPT-3 more, which is it has an API that's the model behind, or roughly the model behind ChatGPT. I have practical use cases, I guess, for the large language models like GPT-3, whereas for things like DALL-E 2, generating art and so forth, that's not so much my thing. So maybe I'm inclined to agree with you that that's the image generation is a little bit more of a toy, but I think that what is possible with the language generation is just mind blowing.
Can you give an example?
Yeah, totally. I mean, one example that we're using heavily for our new company is summarization, right? So one of the things we're doing with our new company is we're taking unstructured data, big slabs of text, and we're turning it into structured data that people can use as an input to their model of, for some sort of analysis. And GPT-3 is absolutely amazing at, let's say I want to pull out some facts out of a big wall of text. It's absolutely, let's say it was a job post and I want to know what does the team do? I just type in at the top of GPT-3, what is the name of the team hiring? And then it will tell me what that team does, which I think is absolutely incredible. So that's a summarization use case. And we at AIX, I feel like we're really at the coalface. People in the venture community say a lot that we're in a world right now where the capability of these models runs far ahead of the applications. So the models are capable of much more. People haven't yet built companies or applications around these models yet, but what is possible, we've just had this explosion of capability, and soon going to see I guess a bit of an explosion in the companies that are being built. And certainly we at AIX are seeing a lot of the kind of early examples of what people are trying to build on this. And one reason it's been an exciting time for us, I mentioned there've been these big developments in the diffusion models and the transformer models. So one of our partners, Peter Abil, is one of the key people behind diffusion models. So it's a lot of his grad students who are doing a lot of the work that comes out of the work around diffusion models and building the companies on top of diffusion models. And then other partner, Chris Manning, did a lot of the formative NLP work that led to the transformer and so on and so forth. And when I talk about NLP, I'm talking about natural language processing, as in the understanding of text. So the thing that is mind-blowing is not only today can you get a very accurate transcription of speech to text transcription of this conversation, but you could also take the transcript of this conversation and say, hey, what did Anthony say about the various eras of machine learning? And it would give you you wouldn't have to read the whole transcript or listen to the whole interview. It would just give you the answers to your question. Did Anthony talk about X? Which I think is, yeah, as I said, just incredible.
Yeah.
Some of the ones I'm excited about. So that team we've been chatting to that are looking at building a virtual travel agent. So, let's say I'm a surfer. So let's say I want to do a surf trip in April. Where is the best place in the world to do a surf trip in April? Well, give me a few destinations and the pros and cons and how reliable the conditions are. And then, okay, can you recommend me a hotel nearest to the best breaks? And then it would give me a list of hotels. All right, great. I want to go from this date to this date. Can you suggest me flights? So you might have, historically, maybe we dealt with human travel agents. Now we mostly deal with these kind of online booking services. Can we get the cost effectiveness of the online booking services by interacting with a travel agent, a chat powered travel agent? Another example of something we're seeing is somebody who's looking to build a personal assistant for every knowledge worker, right? So it's not just the CEO or the C-suite who get a personal assistant, but everybody might get a Chat GPT powered or GPT-3 powered personal assistant. So the idea being it reads all your Slack and it reads all your emails, and so it has full context on everything that has come in, and so then it's able to handle the things you might have asked a personal assistant to do.
Yeah, that's one of the interesting things I think with ChatGPT as well, is that the current version that's out is it has a database up till 2021, but it's not actually live connected to the internet. How will it change the model once it does that?
There's a short-term and a long-term answer to that. In the interim, people are using what are called vector databases. So what you can do, as you know, is you have the model which has knowledge up to 2021, but you can inject new knowledge in through the prompt, right? So, and the way people are injecting the way people have been exploring this idea of injecting knowledge in through the prompt is using something called a vector database. So let's say what a company might do is they might have a lot of the knowledge about a restaurant or a hotel encoded in a vector database. And that allows them to query the latest knowledge on hotels and restaurants while still having the power of the language capability. So that ChatGPT is more used for the language capability, but the knowledge is coming from this vector database, which injects the new and current information into the prompt.
Yeah. So it's to a degree is sort of this old idea of, if you put crap in, then crap comes out. But if the quality of the data is good, then you get more useful results as well.
Yeah, totally.
Let's go back to Kaggle. So you sold that in 2017 to Google. What are they using it for? What was sort of the interest for them to implement it?
Yeah, totally. And the reason for Google's acquisition has evolved over time. But the initial motivation is we were acquired by Google Cloud. And Google Cloud was and still is the number 3 in the market. You have Amazon Web Services, and then you have Microsoft Azure, and you have Google Cloud. But if you think about where Google is particularly strong relative to those other companies, at least historically so, has been in AI and machine learning. And so Google Cloud really had a focus on being the best cloud for AI and machine learning. And Kaggle was by far, and is still by far, the world's largest machine learning community. The company has 11 million data scientists, machine learners signed up. So really a very high fraction of the world's machine learners are on Kaggle. And so what Google wanted to do was use the acquisition to give the Kaggle community exposure to Google Cloud tools and hardware and so forth. So Google has a chip called a TPU, which is a very powerful, an alternative to NVIDIA's GPU. So that was the initial motivation. Kaggle actually moved out of Google Cloud into an area called Core Systems let me remember, somewhere in the 2020 timeframe. And this was actually a really nice thing for Kaggle, because it meant that Kaggle was incentivized not just to have an impact on Google Cloud, but really, was able to take Core Systems as a central core technology part of Google that builds functionality that powers not just one product area at Google, but has a Google-wide purview, and so that gave Kaggle the opportunity to, really have an impact across all Google products.
So I saw on the website there were a couple of companies named, so I presume they're sort of in the public domain, but it has solved problems for companies such as Ford, Deloitte, and even NASA. What were some of the more, interesting or memorable applications?
I mean, one that comes to mind is we did I think it was a $1 million prize with Zillow. Zillow is, like the realestate.com.au of the US, and they have a very prominent algorithm called the Zestimate algorithm. And so what people do is they put in their address, and Zillow pulls information on how many bedrooms and how many bathrooms and when the house was last renovated, whatever information they have on the address, and then they'll give you back an estimate of what your house is worth. And that's become people love checking the Zestimate estimate on, to get an estimate of what their house is worth. So when they first launched the Zestimate algorithm, I believe it was accurate within 12% of the actual selling price. And over time, they were able to, make improvements and improve more improvements and more improvements. They got down to 5%. They got stuck at 5%. And so one of their things was one of their motivations in launching the challenge was, is it possible to get past 5% improvement, improve past 5% accuracy? And it turns out that the answer was yes. One interesting thing about chat competitions, I didn't really explain this dynamic, but it's interesting and worth talking about for a minute. We would show people on a live leaderboard how they were performing relative to each other. So, you'd check the leaderboard and you had, call it 80% accuracy, and you're really happy, you're on top of the leaderboard. But then the next day somebody comes up and they get 82% accuracy. And so, whereas you were really happy, now you need to work till you get ahead of them. And so the fact that we would show people a live leaderboard really motivated better performance. If you're working on a problem in isolation, you don't know where to stop, right? But the fact that you have this live leaderboard, causes people to push to do better and push to do better. So that is how Kaggle competitions would consistently outperform what a company was able to do internally.
Yeah.
We did a challenge, a lot of medical imaging challenges, doing things like taking CT scans and trying to diagnose lung cancer. And one of the remarkable things, the very interesting things about disease like lung cancer is you start off and you get a result from the CT scan, then you ultimately do a biopsy, or you do get an answer like, was there cancer or was there not? So in that case, not only was the winning algorithm able to match is actually able to surpass, what a real live physician could do, because your training data, the physician makes an imperfect diagnosis. The algorithm was actually able to be better because the ground truth data that it was being trained on was the ultimate, was there cancer, was there not?
Yeah.
So these are a couple of, there are a lot of very memorable examples.
Yeah, so maybe we can draw it sort of into the investment industry, because I understand there were a number of investment firms that also submitted challenges to this competition. I think Optiver, Jane Street, Two Sigma, there's a couple of them that put sort of the problems up. What sort of problems were they trying to solve?
Those are all, pretty elite investment funds. And one thing they have a voracious appetite for is very strong mathematical talent. So one motivation was, putting up problems that look a bit like a problem you might solve at a Two Sigma or a Jane Street. And if you do well on that problem, then you might be, as well as winning a prize, you might also receive a job offer. That was one motivation. Another idea that was explored by some of these quant funds was, I don't know if you're familiar with, and maybe some of your listeners are familiar with, there was a company called Quantopian. I'm not sure if they still exist. There's a company called Numerai. These are some companies like trying to build, in some ways, crowdsourced trading strategies where you sort of run these challenges and then they backtest the results. And if your algorithm backtested well, then they deploy your algorithm. One of the difficult things about that model, at least according to some of the funds that we had spoken to, was very hard as a one-man person or one-woman person competing in a competition to do all the aspects of trading like end to end, right? So there's a lot of pieces to building a trading system. First you have to find alpha. Then you have to do portfolio construction, right? So you found some alpha, but then you don't want to have a too correlated portfolio. Then you have to figure out how do you actually trade the signal that you have found so that you don't move I think they call it slippage or something like that, where you don't move the market. And each of those are separate problems that at a fund, you'd have a team for each of these different
Yeah.
parts, right? So the idea that somebody in a crowdsourced kind of setting could do all of those, some of the funds said to us, I think that's a big ask, but you could have individuals do well in the finding alpha piece, right? Or the portfolio construction piece, or the figuring out the optimal trading piece. So we did have some interest from funds in chunking up their problems so that they weren't sort of a full end-to-end trading problem, but rather with some aspect of so just one piece of the pipeline.
Yeah, I remember looking into Quantopian and some of the challenges that you mentioned. I think eventually they closed the fund because it became too hard to implement it all. But of the the firms that submitted their problems onto Kaggle, what sort of problems were they trying to solve? Were they also looking for alpha generating algorithms, or was it in different areas?
Yeah, I think it was a mix. Some of them, as I said, were more toy problems aimed at recruiting, and some of them were, I think, of the areas that I mentioned, finding alpha was probably the one that people believed was the most promising way that the Kaggle community might be able to contribute.
Yeah. But with alpha, it's always the problem that something that might have worked in the past might not work going forward.
Yeah.
And I think I had a bit of a thought about where machine learning and artificial intelligence comes into play in investing, and it sort of led me to the idea that one of the problems about investing and why it's very hard is that you're trying to say things about the future. Does machine learning actually help with that?
I mean, it can. Certainly, the Kaggle setup is harder in what I would describe as adversarial situations. And so some examples of adversarial situations are trading. You're trying to find alpha, but so are other people, and each other's impacts on the market. And other examples of adversarial type problems are spam. You identify a type of spam, and then spammers figure out how to get around it. Fraud is another adversarial. You figure out how to detect form of credit card fraud, and then the fraudsters come up with other approaches. These are all difficult in a Kaggle setup because what happens is you run a challenge, the data was frozen for 3 months or something like that. Then you get the result, then you put it into production. And in the meantime, it might be the case that the approach to fraud had changed, or you implement the algorithm and then you sort of need more of a continuous setup. And actually, I haven't kept tabs on where this landed, but it was something that we were thinking quite a bit about at Kaggle. Like, can we set up something like an evergreen competition where, maybe you award a prize at the end of each month, but the competition never closes, right? It just keeps you keep having the data feeding in and it keeps rolling on and on and on. And I think a setup like that might be better for an adversarial type competition. And so maybe coming back to your question, does machine learning work with time series data when you're trying to predict the future? The answer is definitely yes. But the distinction I would make is your algorithm needs more babysitting if you're working in a in a setting that has an adversarial dimension to it.
So in terms of the investment process, where do you think that it is most useful? And I sort of asked this with the idea that there's a couple of institutional investors in Australia that have been sort of playing around with machine learning models. And actually, where they found the most applications is not so much in trying to find alpha, but more in sort of controlling risk. But what are your ideas around it?
Yeah, I mean, I should say that I've never been a professional trader, and so I sort of feel a little bit of an imposter trying to answer that question. It sounds like you've spoken to people with real direct knowledge. The one thing I will say is the thing that is amazing about the Kaggle community that they do incredibly well is they come up with creative features. If I think about what historically has made for a really good competitor in Kaggle competitions, particularly on structured data, less so on images and natural language and some of the unstructured problems. It's the ability to come up with hypotheses and very creative hypotheses, and then to test them quickly. An example I often give is that we had a competition to predict which cars sold us at a secondhand auction would be good buys and which one would be lemons. And it turned out one of the competition winning insights was that car color had a big impact.
Oh,
And so the person who identified that relationship tested a whole lot of different hypotheses. Just take car color. You have all different car colors, and you know a normal person sees that column and they're like, okay, here are car colors. But a machine learner who's very good at feature engineering will say, okay, well, I can group these into dark color cars and light color cars on the assumption that dark color cars get into accidents more at night because people don't see them. And then they'll test that hypothesis. And it turned out that was no relationship there.
more about the red car?
No, so what they found was that unusual color cars were more likely to be reliable than more standard color cars. And their hypothesis in testing that was that if you're the buyer of an unusual color car, take an orange car as an example, you're probably an enthusiast. Therefore, you look after the car a bit better. And so by the time it gets sold at a secondhand auction, it's in better condition than a standard color car.
Right.
That's an example of the kind of thing Kagglers are very good at. I'll give you another example. We did quite a lot of ran quite a few challenges with defense departments over the years, and we ran one, and I forget what the motivation was, but they were trying to take satellite images and order them chronologically, right? I cannot remember why this was an important use case for them, but for some reason that they needed this done. And so what the winner did was they would look for things like they do object detection on construction sites, and they'd find construction sites. And so construction sites always progress, that get more and more and more built up, right? So yes, there's good machine learning in being able to identify a construction site, but you have to have the creativity to think of of looking for the construction site as a way to order the satellite images, right? And so I think a lot of the best machine learners are very creative in the ways to use lateral thinking to think of clever angles on the problem. And I would assume, again, with the caveat that I've never been a trader, I would assume that's probably also a skill that is quite valuable in finding alpha.
Yeah, for sure. So you're now involved with AIX, which is basically a venture capital firm. What are sort of the type of businesses that you look for?
Yeah, I mean, each of us has a different area of expertise. So I mentioned to you, my partner Chris Manning is pretty much the godfather of natural language processing. So he looks at a lot of the NLP companies. Partner Peter Abbeel is the creator of diffusion models, so has a lot of connectivity with the people building those. So, and also is very big with in the robotics community. For me particularly, if you look at where I guess I have differentiated knowledge, I've seen the kinds of tools that have gotten wide scale adoption by data scientists. So I sort of feel like I have a really good pulse on, where are the gaps in the tool chain of what data scientists use.
Mm-hmm.
Is one area. And then another thing I really enjoy is, I've now been in the field for a good 10 years. And through this, I've gotten to know a lot of very strong people in the field who I respect. And even in some cases, they're building companies outside of tooling, and it's been very enjoyable to back them and to be able to be involved in their journeys. So maybe to give you a couple of examples of companies I've invested in, one that kind of fits into the tooling kind of example, and then one that's a close relationship. Actually, I'll give you two on the tooling. Did a company called Chroma. Now, earlier in the conversation, I mentioned these vector databases as kind of the key to injecting current knowledge into the ability to build a large language model with current context, right? So Chroma is a very strong team that is building a vector database specifically designed to feed these large language model use cases. So that's one example. Another is a company called Mutable. And what they do is, as you're kind of coding as a software engineer or a data scientist, they can do things like predict. You type a little bit of code, they predict the rest of your code for you.
Okay.
Which is really nice. Makes you a much more productive developer. But then once you've finished writing your code, they can then do a pass over your code and sort of clean it up. Very often a software engineering team will have like a style guide. They'll go back and sort of clean it up. And a lot of this sort of work has historically been done manually, and now they've got an AI-powered coding copilot.
Yeah.
Then on the example of being able to back somebody, I've had a long-term relationship with Pete Warden, who was one of the original authors of TensorFlow. TensorFlow, if you're familiar with it, there are two main libraries people use to train machine learning models: TensorFlow out of Google and PyTorch out of Facebook. Pete was one of the original creators of TensorFlow, and then built something called TensorFlow Lite, which is basically the TensorFlow that's deployed on all of our mobile phones. So if you've used any machine learning powered applications on your cell phone, whether it be things like Google Assistant and so forth, there's a very high chance that this was built using TensorFlow Lite, which is deployed on, I think it's 3 billion. His software is deployed on 3 billion smartphones around the world, which is pretty mind-blowing.
Okay.
So he left Google to start a company called Useful Sensors. And what he is doing is building chips, very, very low-powered chips that allow you to embed machine learning in your electronic device. So let's say you had a fan, like a Dyson fan or something. They could have a person detection chip in the fan, so that the fan follows you around the room, as an example. Or let's say you had a gaze detection and speech recognition chip in your light. You could look up at the light and say off, and it sees that you're looking at it, and it hears that you say off. And it's very, very complex to be able to get machine learning to work on, call it $2 chips, which is what you would need to do in order to make a lot of these electrical appliance use cases workable. But Pete really is, first he built, was involved in building the full TensorFlow, then the TensorFlow Lite, then TensorFlow Micro, and now he's helping to get these ultra low machine learning embedded into appliances. So yeah, those are some examples of some of the companies I personally have been involved in.
So what's next for you with AIX Ventures? Are you constantly looking for new companies to add, or what are sort of your plans going forward?
Yeah, I mean, I said this earlier. It's a really exciting time for AIX because it feels like the capability is running ahead of the actual implementation, and so there's just an explosion of companies doing incredibly useful things. So I sort of feel like it's really an exhilarating time, both to be, someone building a company leveraging AI, as well as investing in other companies leveraging AI.
Yeah, fair enough. All right, let's switch now to Chris Manning. So Chris, you are professor of machine learning with Stanford University and also an investment partner with AIX Ventures. Chris, how did you first get interested into this space, and especially the natural language processing part of it?
Yeah, so really where I started off was an interest in doing things with computers and human languages, natural language processing. So as a high school student, then sort of heading into undergrad in Australia, that, I happened to see a little bit of the idea of linguistics, this idea you could sort of look at the science of all human languages, what's their structure, how are people able to understand them, how do tiny kids manage to learn these complex things, even though people struggled so hard in high school and university to learn different languages. And so that fascinated me. But then I was also, well into doing things with maths and computer science. Well, at least doing stuff with computers, playing around with TRS-80s or Apple IIs or whatever there was around those days. And so I was sort of enthusiastic in putting those together. And so that led to my interest in computational linguistics or natural language processing. But, while I was an undergrad, I mean, machine learning was sort of really only in its beginnings, right? It was seen as this kind of pretty sketchy bit on the side of artificial intelligence. But actually, one person, really the only Australian who was prominent in machine learning in the 1980s, was Ross Quinlan, and he had developed this method, ID3, for decision tree induction. And so really, during my undergrad and in my honors thesis, I started doing things with ID3, and one thing led to another from there.
Yeah, right. So can you tell me a little bit about your current focus of your research?
Sure. So starting in 2010, I guess, the big focus of my research has been doing things with artificial neural networks, otherwise known as deep learning and natural language processing. So really for my whole career, the change that I've been at the forefront is using empirical methods, working from lots of language data. That's something that just started to become possible around the years when I was working on my PhD. This was slightly before the World Wide Web began, but there started to be sources like Newswire, parliamentary proceedings, legal things, where you could start to get quantities of digital text, and that just opened up this whole new way of thinking about describing, learning human languages compared to sort of the old-fashioned AI approaches where it's sort of really by hand writing rules for grammars and in other areas of AI, expert systems and those other things from the 1980s. But in the 90s and the 2000s, we were using probabilistic models for natural language processing. In the late 2000s, people started to show some promise in going back to neural network methods. And so I got into that early, and that really worked out great for me.
Glad to hear. So what are some of the major improvements that you've seen since sort of those early days to now?
I mean, there've been a whole succession of major improvements. So, neural networks in the earliest days for natural language, so this is word vectors. So the idea was we can represent a word by a big vector of real numbers. That sounds a really weird idea when you first see it. You're going to take a word like house and you're going to say, okay, that's a vector of minus 0.127 plus 0.65 ... for a lot of numbers. I mean, that doesn't seem to add much value, but effectively we can learn these vectors in such a way that they can represent all kinds of similarity relations between words. And having that great model of word meaning similarity already lets you do interesting things in NLP that you couldn't do when you just treated words as symbols, the sequence of letters of how we spell them. But since then, a number of other major improvements have been made. So there have been new developments in neural network types. So in particular, we went through sort of the popularity of sequence models like LSTMs, the invention of having attention as a kind of content addressable memory, which led to sort of big advances in machine translation, summarization, and other things. And then some of these new ideas of how to build neural network models came together in the transformer architecture, which has just become the exciting technical architecture that's powered the last 5 years. But beyond simply having that architecture, there was another discovery, which in retrospect is very simple, but it actually took a while for people to have this idea, which was that no matter what kind of language understanding or generation task we might want to do, we could build a very powerful general language understanding and producing system by training it over vast amounts of data to do a very simple task, which is just predicting a word in context. So given some context, predict the next word that will appear in the text. And that's a really convenient task because You don't need to have humans sitting around labeling data or anything like that. All you need is a pile of text, and you can play this game of, I'll show you the first 10 words, predict the 11th. I'll show you the first 11 words, predict the 12th. But that allowed the training of these very large high-parameter neural networks, which led to things like BERT and GPT-3 and ChatGPT on that task. And that gave revolutionary new capabilities. And that takes us most of the way to the present. But, for the last bit of the present, for what you're seeing with ChatGPT and similar models, is now people layering on other kinds of training on top of that, of instruction fine-tuning and in-context learning, to have these models much more be things that you can say what you want them to do, and they'll do it.
Yeah, I looked at your CV, and it's sort of stated as a research goal that you wanted to achieve that computers can intelligently process, understand, and generate human language material. So you mentioned just ChatGPT. How far are we off that goal?
I think for everyone, including people like me who've been doing natural language processing for 20 years, it's just amazing the progress that's been made in the last couple of years. And, models like ChatGPT, they're just great, right? That you can ask them to produce things, and they'll produce paragraphs of coherent, well-written text. And this is amazing. And you can also use them for all kinds of natural language analysis and understanding tasks. It used to be the case we'd train all of these systems for things like sentiment analysis or relation extraction. But, now you can just say to ChatGPT, here's a paragraph of text. Is this tone, neutral, positive, or negative? And it'll do sentiment analysis. You can say, in the text, which people mentioned being hired by Microsoft, and it'll tell you their names, right? It'll do that kind of information extraction. So that, it'll just do a ton. I mean, does that mean that all problems are solved and I should put my feet up? No. I mean, there's still very active research. So, there are particular problems that people have noticed with these large language models. They tend to hallucinate facts when they don't actually know the answers. They sound just as confident saying made up stuff. That's problematic. There's, although they're very good, they don't actually maintain a consistent model of the world. So very often, if you have extended pieces of text, they'll say things that contradict each other. So whereas humans have more of a sort of a model of how the world is in their heads, and mainly keep consistency with that. Another area that I'm interested in doing research in is, essentially these models have been really exploiting scale. So they're not very good at learning from the language they hear. But if we feed them truly humongous amounts of language, like 10 billion words, then they can do a very good job. But that's sort of both scientifically uninteresting, right? So little children, right, they can become very good language users, being shown about 50 million words of a language. And so, that means that, human learning is much more efficient at getting signal from data than our machine learning. And so as a scientist, we'd like to be able to do that. But then also in the practical world, well, if you want to train a model on 10 billion words, you can do that in English, you can do it in Chinese, you could do it in a few other languages like Spanish and German, Hindi. But, the vast number of languages in the world, no matter what you do, there just aren't 10 billion words available in that language. And when you get to sort of genuinely small languages, there might not be, you mightn't be able to get 100 million, let alone a billion. And we'd also like to be able to provide language technologies to speakers of a much broader range of languages. And I've been interested in doing that as well.
Yeah. Anthony sort of mentioned that there is a bit of a problem at the moment that the user experience hasn't quite caught up yet with what the models can do. Like people interacting with them, they sort of feed them very simple tasks. and haven't really explored the full range of the capabilities of these programs. How do you look at that? What are some of the applications that are maybe not obvious that you're interested in?
Yeah, so I think that's right. I mean, so this is essentially what I'm interested in, both for teaching at Stanford University and in being an investment partner for AIX, that we've actually had these enormous technology advances in building AI models. And, I'm concentrating on natural language processing, but these same techniques are also delivering amazing results for vision, robotics, in bioinformatics, for proteomics and genome interpretation, right? There's sort of these amazing new technologies, and it feels like there's this big technology overhang where there are these great new capabilities, and most of the world hasn't yet taken advantage of them. And I think now we're at this point that they're just all kinds of places. So, to a large extent, companies, operate over human language. That, yeah, there are some spreadsheets and things like that, but, you've got people doing sales, there's people doing support, there are people doing marketing, there are people transferring information in between the different divisions of a company, there are meetings, there are decisions on strategy. All of that stuff is happening in human language. And in all of those areas, there are opportunities now to make use of these large language models to have people perform work faster and better. So in most cases, it'll be as a tool assisting humans. But, if I'm someone that's involved in copywriting and marketing, rather than sort of sitting around staring at my blank sheet of paper, wondering how to word things, if I've got sort of a few ideas of themes, I can say, write some copy that advances these themes. Why not write 5 of them? And, you can have the model suggest 5 paragraphs, and then, well, maybe you might want to pick some of the best ideas from several of them. But, either way, it'll just allow your work to be done faster and often better.
I think you mentioned earlier about sort of the interaction with languages and the different type of languages. And it made me think of a blog post that I read on one of the Google blogs that was talking about the engine behind the Google Translate system. And I think they were experimenting with a few different techniques. And one of them was called a zero-shot translation, which effectively tried to translate one language to another where it hadn't encountered one of those languages. They hadn't actually fed it information on that language. And so it was sort of doing it on the fly. And from memory, it sort of said in his blog post that this program started to invent its own language to make it a more efficient way of translating between these languages. And after that, it was shut down because we were quite concerned about this new language that was being developed. What is sort of going on there, and why do you think that they shut it down?
I think you're actually they're crossing between 2 different stories, to be honest. I think the shutting down one was experiments that were done at Facebook. So maybe let me answer about both of them separately.
Sure.
So for machine translation, so machine translation was a huge success of neural networks, starting, with research about 2014. How well it worked was just so enormously better than the methods that have been used previously. It was essentially made it from sort of first research attempts to everyone was using in production by 2 years later in 2016. But, starting off the way people built neural machine translation systems was the same kind of setting that people had used previously to build translation systems, which was you're building a translation system between one pair of languages. So we were building, say, a Chinese English machine translation system. And so in doing it in an empirical way, you'd first of all collect a lot of data that had been already translated between Chinese and English. And, there are actually quite a few sources of that. I mean, including, handy places like Hong Kong, which translates a lot of material between Chinese and English. And so you train a model based on how things are translated to be able to translate more stuff. But once people started building much bigger neural networks, it turned out that you could do this amazing thing. So rather than sort of just training for one language pair, you could train a huge neural net that is designed to be able to translate between any pair of languages. So what you do is when you're feeding in a sentence, you first of all sort of tag it with a tag at the beginning saying, this is English, or this is Uzbek, or this is Danish, whatever the language is. And then it sort of reads through that, and then you give it a tag for what language you want it to translate to, and you say Chinese or Lithuanian or whatever it is, and then it will proceed to generate word by word the translation in that language. And somewhat surprisingly, doing things that way in a large neural network works. It's not only that it works as well as training a system between just two languages, it actually works better because the big neural network can share information and structure between the different human languages in a way that it helps it. Obviously there are quite a few languages that are related to each other. So, you might expect that Italian and Spanish can help each other. But, languages also, lots of languages now have English loan words in them, and they can help each other and so on. So you get benefits across that. And so you end up with kind of general representations of each language and a general ability to sort of align between languages. And so the zero-shot translation was then this amazing result, which is, for major languages and major pairs of languages, you can collect a fair quantity of translation. So for English Chinese, English Spanish, English German, you can collect lots of translations. But, if we take more minor languages, so if I take something like, I don't know, Lithuanian and Indonesian, no one translates Lithuanian into Indonesian or vice versa. So there's no training data. But once we've trained this big neural network so it can translate Lithuanian into Russian, Lithuanian into English, and we've got English into Indonesian and whatever else, Dutch into Indonesian, that actually you can, with these tagged languages, you can just tag the input and say, this is Lithuanian, and tag that what I want to produce is Indonesian. And so then it can quite well translate between those two languages, even though it's never seen any parallel text of sentences translated between Lithuanian and Indonesian. Do you want me to go on and tell about the shutdown one?
Sure. Yes, go ahead.
So this was an experiment where Facebook, then now Meta, was wanting to train a pair of language using AI systems to communicate with each other and do tasks so that they could negotiate contracts or buy and sell stuff and things like that. And essentially they were getting the models to learn as they went so they'd be better at executing tasks. For what they had and for what they were learning, what happened was that the models, they started off having been trained on English, but they didn't stick to English because there's really no reason for them, right, to do so, right? That as time went by, they could just adopt their own sort of efficient communication symbol system and transfer like coded messages, just efficient symbol patterns to represent different meanings between each other, and that they looked nothing like English anymore. And so this was they shut it off. Now, I actually think that story was blown up out of all proportion by the media because, it was sold as, the computers went rogue. They started speaking a secret language that humans couldn't understand, and people had to reach for the power plug before something went badly wrong. I think that's sort of a big exaggeration. I think, something went wrong. The researchers hadn't thought through this experiment very well. They somehow imagined that these models would stick to English, but start getting better at using English to do negotiations. But what they hadn't thought of was, in this sort of closed loop context of these two artificial agents, there was no reason for them to stick to English. The reason we stick to English when we're talking is because, all the other people it depends on which room you're in, but in the common situation in Australia or the US, all the people in the room can speak English. And so you wanting to say things that are broadly understood, so you don't start inventing, your own private code between two people. And so that's part of the constraints of human language, but also of computers that want to be able to communicate with humans, that they need to have this shared understanding of language.
What are some of the more interesting companies that you've been involved with from the investment point of view with AIX?
So there are lots of different areas of using machine learning AI involved in various kinds of predictions and different ways of doing things. One company we're funding is Atmo, and Atmo is aiming at doing sort of next generation weather prediction. So, there's an established industry of sort of doing weather prediction, and it's pretty good in first world countries, but it's done on very expensive supercomputer hardware, so that people, including the Australian Bureau of Meteorology, are sort of buying, multi-million-dollar huge supercomputers to do physics-based weather simulations. And now it seems like by using clever deep learning approximations and more modern GPU, graphics processing unit acceleration, widely used in neural networks, that you should be able to predict weather actually better using much more modestly priced hardware. And so that's the market that they're developing. And in the first instance, they're aiming especially at all the countries in the world that haven't been putting millions of dollars into buying computers for their Bureau of Meteorology, which is sort of, most of the countries outside of the first world. So that's one cool idea. Another one that's away from language, that's a fun company, is Useful Sensors. So Useful Sensors is trying to see what can be done with what's called edge computing. That's putting machine learning models in little devices that are at the site of things. So, traditionally, a lot of computing went up to the cloud. Things on your phone like speech recognition, or you're doing machine translation, or recognizing the text in a menu or something, right? That it was sending pictures or audio waves up to the cloud, and all happened there. And so in the last 5 or so years, much more computing is being done on your phone, so that things like speech rec now happen on your phone, which gives a much better and faster experience, and also means that if you're using your phone in some foreign country where you don't have a mobile plan, it'll still work and do speech recognition. But you can actually go much lower end than that now, right? That you can now get sort of teeny little computers, CPUs that kind of sell for like literally a few bucks, so that you can get a $3 system. Like, these are kind of some of the boards that hobbyists also use, like Arduinos and Raspberry Pis and things like that. But even lower end than that, right? A Raspberry Pi is about I think it's about $10 US, so whatever that is, about $15 Australian. Whereas you can even go an order of magnitude down from there, and you can still put limited speech recognition systems on them, things that'll understand a few words, or you can put vision systems. So that means that there are things you can do, like, take a tap and you can put one of these into it. And so then when your hands are covered with something sticky, gooey, or bad, rather than having to hold the handle to turn it on anyway, you could just say tap on, tap off, and it would do it. And, so there seems like there are just lots of ways in which you could give sort of a new generation of consumer products where you're only actually adding a few dollars to the bill of materials, and you could use and provide some of these sort of next generation capabilities.
Yeah, for sure. So if we look at sort of the use of MPL in the investment context, a little bit earlier you mentioned, for instance, that these systems could potentially get the mood of a certain piece of text. Can we extend that, and can these systems sort of get a mood of the market? Can they interpret market sentiment by reading just a lot of different text?
Yeah, sure. Yeah. Yeah, I mean, I'm not really an expert in finance, but I mean, there's no doubt at all that these systems can do a very good job at evaluating text data. And I mean, although there's been a lot of use of numeric data in finance, and there's an obvious reason why it's important, on the other hand, markets are meant to be moved by fundamentals, and most fundamental changes are actually expressed in human language again, like in news reports. That's when there's sort of a strike in the mine in Bolivia or something like that that's going to have material impacts on a company. And so you can learn that from language. And then some of what happens with stocks isn't actually really fundamentals. It's then, mob psychology as to how people feel about different sectors. And again, much of the best evidence for that is coming through on language. So, both for getting more factual information and sentiment, yes, you can do it with large language models very well and very flexibly.
Yeah. Question is whether you want to or not ignore the fundamentals. So how did you get involved with AIX? I know that Anthony is an Australian. You're an Australian too. Is that the nominating factor, or?
Partly. Yeah. So, I mean, in some sense, I'm pretty close to the sort of center of how AIX started, but it wasn't actually me that started it. So the beginning of it was really between Sean Johnson and Richard Socha, thinking that there are good opportunities for AI professionals to do more and have a productive role in AI investing. But, in terms of rounding out AIX, well, Richard Socha was my former PhD student who had then gone on to found a couple of companies. Sean Johnson, well, so then two of the other investment partners, Peter Abil and Suchi Saria, had also done PhDs in the Stanford AI Lab during my time. And then Sean Johnson was both a former roommate of Peter Abil's, and he was working as the head of product of another of my former PhD students, Spence Green, who was then, then and still running a company, Lilt, that works on using machine translation in a kind of editing interface to help human translators. And yeah, then me and Anthony were Australian. So, there was a sort of a fairly close connections between this group of people coming together. But yeah, the overall feeling was that there are these great opportunities in technology, and it'd be good to get more technology, AI technology, out into the world. Well, one way someone like me does that is by educating young people on what are the possibilities. One way that people like Anthony or Richard are doing that is by founding and building companies. But we sort of felt that there was the opportunity to do more. And although there are lots of VC funds who are now wanting to say we're AI funds and we're doing AI, a lot of them are exactly the same ones that 6 months ago was saying it was all about crypto. And, most of them don't actually have much depth in artificial intelligence, which is a highly technical field. And so we believe that both in terms of being able to decide which companies were promising in terms of, which people really understood what they're doing, what potential product ideas were or weren't realizable with current technology, but then also in being able to help early stage companies be successful, that we could just offer more from the AI expertise side than other venture firms. Now, of course, it's not all about AI expertise. There are all the other parts of building a company as well, as to, finding a market, working out an initial sort of beachhead where you can start to get traction, etc. So that's where the full-time team also comes in, that you need to have the rest of the competencies too. But nevertheless, it's really depth of AI expertise that gives us our differentiating special factor.
Yeah. Does it also give you sort of ideas in how to bring concepts across when you teach students in terms of including some of these real-world applications and translating that to an academic context?
Yeah, absolutely. I've actually been finding that valuable because, although I am and have been for a long time, an AI professional in the sense of being an academic, if you're only an academic, you might be up on all the latest research that's being published in papers, but it's not that you're naturally seeing a great deal of what companies are and aren't doing, wanting to do or not able to do in terms of using technologies in the world. So, we've been doing this for a couple of years now. We started our fund AX Ventures in 2021, and I feel like it actually has been really valuable in giving me a broader view and more insight into what are the possibilities and how AI is starting to be used in commercial applications and what more might be done.
Yeah. So if we can end up with a little bit of crystal ball gazing, ChatGPT has made a big splash and people are still working out what it all can do. What do you think is sort of the next iteration? What is the next big thing in this field?
Great question. Yeah. So I think, there's no doubt that there's going to be continued progress in making larger and better language models. And so some of the things that we're already seeing taking off, where these models are to a certain extent able to, plan and reason, that they'll get better at doing that. But in terms of where the most distinctive advances are going to happen, I think they're likely to be in doing much more with multimodal models that go beyond just language, but then also have images, video, commands, connecting to the world and devices and things like that. So, we've already seen a couple of fantastic things. So whether it's Stability AI, Midjourney, or DALL-E 2, right? We've had these great models where you could put in some text and it'll produce a picture for you. But, there's a lot more that can happen there. And all of these things will get you closer also to having a model that has more of the richness that human beings have of understanding an integrated sensory world. So to mention a couple of those, it's just starting to become possible to do things in generative AI with video, or, if you wish, it can be animation style video. And I mean, I think the opportunities there are just fantastic, right? It's sort of extremely expensive producing animation or video, and to the extent that a lot more stuff can be cheaply, so rather than Hollywood special effects where it's costing millions and millions to produce something for a scene, that kind of cost can be coming down orders of magnitude. And so I think we could easily reach the point where sort of not high-end videos, the kind of video they play you when you get on a plane to give you the safety instructions, that we'll be able to be doing AI production of those kind of videos. And, that's by far the biggest amount of video work is actually corporate videos, right? Not the super expensive end that we watch on movies. And, there are just enormous opportunities for cost savings there. But then the other direction is using these language models to much more hooked together with the world where actions are taken, so that rather than just the model producing text, well, it'd be actually nice if it could book your movie tickets or arrange for your address to be changed, all of these things that are sort of fiddly and tedious where you're manipulating web pages. It'd be really nice to be able to outsource those to your foundation model assistant. And I think that will actually become possible over the next couple of years. You just have to watch carefully what it's doing to make sure it's right.
For sure. That sounds very interesting. So definitely video is next, and then the personal assistant of the future. Well, Chris and Anthony, thank you very much for your time. I've learned a lot this episode.
Great talking to you.
Yeah, thanks for having me.
Thank you for listening to the i3 podcast. For more information, please visit www.i3-invest.com. Thank you very much.